Thank you again. Next up, we have an interesting talk on location services I'm going to go with the last name, Regula, because I'm still working on the first name. But yeah, round of applause for Regula. He's going to be talking about locating macOS users without their consent.
Okay, can I start? It's 4 minutes before, yeah. Okay, so hello everybody. I'm very glad to be here again. My name is Wojciech. and first of all, we need to answer the most important question during this talk. Because at least in Poland, it's not Waldo, it's Wally. So raise your hand. So raise your hand if you have Wally in your country. And Waldo. So it looks like Waldo is probably the American name. Yeah. So why did they change it? Like Wally is perfectly fine, right? Yeah. But coming back to the talk. So today we're going to talk about bypassing location access consent. I'm head of mobile security at Securing still. I'm an author of Certified iOS Application Security Engineer course, which is a course for both iOS developers and pen testers that want to make their applications secure. I'm mostly focused on iOS and macOS application security. And from time to time, I still have a blog, which is wojciechregula.blog. I created that domain name before I knew my name is not pronounceable outside of Poland, so feel free to use the alias for this domain, which is osx.zip. It will redirect you to the domain. Yeah. And the plan for today is that I'm going to quickly introduce you to TCC, privacy fundamentals. This is Objective by the Sea, so I guess I don't need to explain what system integrity protection is, so that will be just a shortened version of introduction. Then we're going to talk about location services, because you will see that's kind of different from the TCC itself. Then we're going to talk about attack surface for location services, because this is quite interesting. And then some vulnerabilities. So there will be a few categories of different vulnerabilities you will see. Some of them are old, some of them are new. But I wanted to show you some different kind of vulnerabilities to present you that location services can be attacked from different perspectives. And at the very end, I will click to the next slide. There will be, I don't want to spoil it at this moment, but at the end of this talk, I will show you that vulnerabilities are cool, but you can achieve the same without even touching them. There is you will see. So let's start from the TCC and privacy fundamentals. So I think everybody at this conference knows what SIP is. When SIP is enabled, the TCC comes into play. Without SIP, you have macOS like a 30 years old Linux without any boundaries between the same UIDs, etc. So please keep your SIP enabled. I think that's pretty obvious. But TCC itself, when SIP is turned on, it protects your privacy. And the thing is that not even root can approve your TCC permissions, and that's important, because for location services, this is the same assumption. So even if you have root, you should not be able to get user's location. That's a privacy. And there's one interesting thing that you may not know about TCC, that from macOS Ventura, TCC also protects containers of sandboxed apps. So usually if you come from other operating systems and you hear sandbox, you think that, okay, so if my application is sandbox, it should not be able to get some data from outside of the sandbox. So this is right from the inside. The protection is usually from the inside to the outside. But from macOS Ventura, it changed. So it's also from if your application is sandbox, it means it has its own container. So in theory, now TCC also protects these sandbox apps from the outside. So that's maybe not, that's an extension to TCC, which maybe you didn't know about. TCC is still growing. Again, in macOS Tahoe, we see new protections added by the TCC. It became a really huge framework, really granular. So this is just a reminder. And here's the thing I want you to focus on. So in TCC, we have an SQLite3 database. There is one global TCC database, and per each user installed on the machine, there will be a separate TCC database. And all of these databases have the same structure. There's an SQLite3 database. So we have the service, which indicates the category of the protection, the bundle ID, auth value, which states like user accepted, or not, the prompt has not been yet presented, and code signing requirement. And the quotations mark are here because it's of course in binary data, so we need a way to decode it if you want to understand what actually is in the TCC database. So this is a simple Objective-C code that you can use to reverse that code signing requirement to a human readable form. And that's a quick introduction of TCC. Let's now focus on the more important part, which is location services. So even though there is a KTCC service pool TCC permission, which is actually known as location permission, on macOS, it will not give you access to the location. So in practice, there will be a separate daemon, which is not TCCD, but location D. And the location permissions are not stored in the library application support Apple TCC, but in location D client's playlist. So we'll see that even though there is a PC permission for that, there's a separate subsystem, and also the database is a separate thing, right? It's SQLite3 versus a playlist, which is of course like kind of XML, right? So this database is probably a separate database because of some legacy stuff. I don't know, to be honest. It had its own problems because that's a different parser for sure than comparing to SQLite3, etc. So there is still an attack vector on attacking playlists. As I told you, it had some location services related problems due to the fact that there is a separate playlist, but let's skip it for now. So what you need to do in a normal way to get users' location. So if your application is sandboxed, your application must have a Apple Security Personal Information Location Entitlement to ask for location services access. And you also need to do some changes in info playlist. But if you have a full control of the application and you may not put it in the sandbox, and you don't have hardened runtime, you don't have to include any of this. So there will be just a prompt like that. This is the code that is required to get the location data. It has, of course, three modes, like when in use, always authorization, and temporary full accuracy. Yes, I still use Objective-C for everything I code. I think Jonathan appreciates this. I don't know if he's on the stage, but yeah, still Objective-C. I never learned Swift properly, I'm sorry. Yeah, so let's talk about something more interesting than the internals of location D. So attack surface. Now we know that we have two separate databases, so let's focus on the plist, which actually contains all the things related to applications that are allowed to get your location. So this is a plist. Let's extract it to more readable form. So let's take Firefox, for example. We have bundle ID, which is stored, executable path, bundle path, and the code signing requirement in the human readable form, which is great. And which of these you think is bypassable? Do you think all this data is like it cannot be changed? Any ideas? I can help you. Bundle identifier. It is not verified, so you can set an arbitrary bundle ID, even starting from Apple, so that can be bypassed. Executable path. In theory, on modern macOS versions, the executable path is within the applications directory, and it should be locked after first use. So in theory, on modern macOS versions, that should not be bypassable. This is the same for the bundle path, and code signing requirement should be fine, right? It is theoretically secure. It is used by many different daemons on macOS to verify and some, very different stuff. So in theory, that should be secure. So let's do an experiment. Let's take this Firefox, copy and paste it to temporary directory, and let's launch them in the same time, and we'll see what's going to happen in the logs. So we have location D. Because the Firefox I launched, I wanted it to get the location access, of course. So the location D is making the decision on if to grant access or not. And here we have the original Firefox from /application/Firefox, and the second one from the TMP. And we see that the client has been authorized for location. So it looks like location D doesn't care if it has been moved from the directory that was saved in the client's plist or not. So what is actually checked? So after playing with location D, I determined that the only thing from the client's plist that is actually checked is the code signing requirement. But is the verification of code signing requirement secure? So let's take the human readable form of it, and let's see. So again, in code signing requirement, we have the bundle identifier, which we know we can change, Apple generic. So if we pay for a certificate, we should be fine. We can have Apple generic. But here is the most important part, which is the team ID. So unfortunately, if we are not able to get Firefox certificate, we should not be able to spoof that code signing requirement, right? But this is the same problem that TCC has. This is vulnerable for downgrade attacks. So we can take an old version of an application, inject a dynamic library to the old version of the application, and still we'll be able to access user location without the additional consent, right? We take an old binary and we got it. So we can, if we want to check if our executable, the old one, is vulnerable for code injections, just look for the flags set to none. And I made a whole blog post about it, so if you're interested on learning more, you can visit my blog with the alias osx.zip. And let's see on how the code signing requirement looks in details when we have different versions. Actually, it is the same. Up-to-date application with hardened runtime enabled has the same code signing requirement as the old application without hardened runtime enabled. And the same as old application without hardened runtime enabled with our dilib injected. Because the only thing which is verified is the main executable. So all the dilibs that are injected, like macOS will not care about it. So location services then have an architectonical problem with downgrade attacks, which we can abuse later. And there is also another thing, which is a responsibility problem. So if Firefox, for example, has a child process, it will inherit all the permissions that the parent had, so Firefox had. So if Firefox spawns anything, the child will also have the TCC permissions. In this example, it will be location services permissions. I made a DevCon talk about it 2 or 3 years ago, and I released an open source tool that auto-exploits that. So if you want to play with it, feel free to use Electronizer. Okay, so this is the first part of the attack surface for location services. Let's see if there is a way to get users' location, maybe not that precise, without even touching the verification of code signing, etc. So the typical ways are by IP address, region settings, time zone, Apple local, and there is a funny thing on macOS Sequoia. Also, SSIDs have been restricted. There is no public information about it, but surely if you, on your, for example, macOS Tahoe, you use this command, even with sudo, there will be SSID and BSSID reducted. If you grant WDUtil location services permission, you will see that. So this is an interesting change. Of course, when I observed it, I wanted to bypass it. So I created some Objective-C code that usually were able to get the SSID and BSSID. So it looks like Apple did a really deep change, because even if you call it from your system APIs, it will be still restricted. And if you open logs again, you will see that there is a location services block BSSID access for XPC connection, and it will check for entitlement. So there is a new thing that is protected by the TCC. Wink, wink. Great. So now let's talk about vulnerabilities. The first vulnerability I'm going to present you is pretty lame, because it's just logging. Again, logging. So before, a few years ago, it was a trend for TCC bypasses by using grep. Nowadays, mostly the logs on the file system things are gone, so we switched to logging, which is accessible to all the unsandboxed applications. So yeah, the weather app is a great example, because weather needs to know your location in order to give you a forecast. So yeah, the problem is that with the forecast, it must send an HTTP request, and the problem with weather app is it was locked. So this is the first easiest location services bypass, a lame one, as I told you. Another CVE, again, within the weather subsystem, in this example, in weather widget. So the same story, it has to have your location to give you a forecast. But in this example, I was able to mess up with the weather data apple.com. I mean, I just broke a route to this domain, and there was a crash, and the crash was locked. So again, next bypass, next unrestricted access to user's location without their consent. And the third one, the third vulnerability I'd like to show you is quite complicated. This is a new one. There is an interesting story behind this vulnerability, because now it is finally fixed. It required 3 fixes from Apple to fix it correctly. I got paid 3 times for the same vulnerability, which is I really appreciate that, actually. But yeah, this is only the first part of this vulnerability. I'm sorry, probably I need to make a separate talk on this vulnerability patches and bypassing the patches. It was really funny. But actually, we know that there are a lot of services on macOS that need to send your location to a server to give you a forecast, to share your location with your on Find My, to get your location using Apple Maps, etc., etc. So there is a lot of network traffic with your location, and I wanted to see if it's possible to somehow intercept that traffic. So actually, it is really interesting that modifying HTTPS proxy settings do not require any additional consent. So the only consent a user must grant during this setting a HTTPS proxy thing is adding a trusted TLS certificate. But it is really easy to be bypassed, because there is an security authorization DB command in which we can change the behavior of the authorization prompt. So if we have root permissions, we can change it so there will be no prompt asking us to add a trusted TLS certificate. So the whole exploit is tweetable. This is all the exploit. Setting the HTTPS proxy, it does not spawn any prompt. This thing will make the prompt not being even presented to the user. It will be just automatically added. I mean, yeah, there will be no prompt when adding a trusted search. And the third command actually adds the search. So after these 3 commands, I was able to set an HTTPS proxy with a trusted TLS certificate. And yeah, by abusing that fact, I was able to spot some applications without certificate pinning and get the location. There is another vulnerability in this time in CF network. It's just like a standard framework for networking on macOS. The only thing that's important is that core services has CF network in its dependencies. You can use dilib3 to observe that. So mostly every application on macOS will have CF network linked. And again, it was a pretty easy vulnerability, pretty easy to exploit. Just set this environment variable to 1, and all the HTTPS requests were logged. So yet another way. This is also an interesting story. You probably saw it because that's an old bug I already presented. So let me just remind you, there are some services on macOS that have private iCloud entitlements. And if you have such an entitlement, you can query the keychain to give you iCloud token. And with iCloud token, among others, you can get users' location without their consent. So this is it. This is how the exploit works. In the background, it refreshes the Find My, but it's only a location example. But with this token, you can access many more things in the iCloud. And this is actually interesting because recently at the latest ASB categories update, there was a statement that no broad iCloud data has been ever. I think that's a broad access, right? If you can leak a token and access all the things a user has stored on the iCloud. So I think I would consider it a broad access, but I don't know the definition of broad maybe. Great, but I showed you some vulnerabilities, the attack surface, the things on how you can attack location services, but there is one thing. Do you have browsers installed on your machines? And do you have them granted location services access? I mean, you probably want to use Google Maps or Apple Maps, or you want to order a taxi via your browser. So yeah, browsers on macOS, especially third-party browsers, are not known for client isolation, I would say. You can influence browsers, for example, with Selenium, and that's a feature. That's actually a feature. Browsers have features to be instrumented because, for example, UI testers use that to verify if the web applications work correctly. So with Selenium, for example, we can load our own JavaScript code and instrument the browser to get users' location and return it back to the terminal. So I wrote a simple Python script to present that. Here, let me stop for a while. You can see a special URL, right? Like Chrome settings. Usually, for example, when I would like to visit Google Maps, there will be a prompt, but there will be not a macOS prompt, but a Chromium prompt asking you if google.com should be able to access your location. If you use this special handler, there will be not such prompt. So if Chrome has access to your location, that bypasses everything. If you use that handler. And coordinates are back in our terminal, so yeah, we abuse browser. And that's not even a 0-day. This is a feature of a browser. Here we have the code if you are interested in trying that at home. But what about Safari? Is Safari vulnerable to such attacks? Actually, the technique I've just presented will not work on Safari, but there is my vulnerability that hasn't been yet presented, so that's the first time I'm presenting it. So it is a web archive, which is, I think you probably heard about it. I think like 5 years ago or 6 years ago on OBTS, there was a presentation about 100 days and the web archive, stored accesses, etc. There was like 5 years ago, I think, on OBTS and Hawaii for sure. So there was a fix for that, but not a complete fix, which I abused. So you can have a web archive, which will point to the domain you want and will trick Safari to get your location without your consent. So as you can see, we have google.com with the checkbox set to allow. Now let's see the content HTML. Just, getting the location, nothing more. This is our web archive, which has this HTML file base 64 encoded, and here we specify the domain. So now, if we open the web archive, location is leaked from Safari. So yeah. And this is actually a vulnerability. It was fixed. Great. So let's sum everything up. I don't want to leave you without recommendations, especially there are some people from Blue Team. So as you can see, location services are something different than TCC. They have their own database, their own problems. You can bypass it with some with downgrade attacks. You can abuse the inheritance problem fact. So for the first thing, you need to detect apps launched from non-standard directories, because usually your users will be running them from /applications. For the inheritance problem, you can detect them using the inspect argument. Dilep injections can be detected by, just verifying the build insert libraries thing. And you need to understand that browsers can be instrumented. So if you want to detect such attacks, you need to monitor what's happening with your browsers. Great. And as in the audience are people from MDM and EDR, I'd like to tell you that I work for Securing. We do pen tests. We have all the papers. Actually, there are some clients sitting here in the audience, which I'm really thankful for. So if you'd like to have a pen test, an external certification of your products, feel free to reach me out. We even work for 2 funk companies, so I think we have all the papers required. So I will be probably the person who will test your macOS and iOS stuff, so if you want, feel free to reach me out. And yeah, that's it for today. Thank you very much for listening. Do we have any questions?